Hey y'all, welcome back. I'm a little tardy with this video, but you got 2 days to get this assignment done, so let's go to the mansion. So we are solving quadratic equations using square root. We are familiar with square root and that symbol and what it looks like. Boom, boom, pew. So real quick vocabulary, you know how I am. Squaring. That's the opposite of square root. It's multiplying a number or a term by itself. So we have 3 squared equals 3 is the same as 3 times 3, which equals 9. You can also add in there, if I have x squared, that means x times x, right? Then we have our square roots, the opposite of squaring, so it means to undo squaring. If we were squaring something, to take the square root of it would be to undo it. The square root of 16, because it's a perfect square, ends up being an exact 4. And then that check is right there at the bottom. So now we're going to solve quadratics with the square root. So we're solving quadratic equations. The reason it's a quadratic equation is because of this squared right here. When they are squared, that's our quadratic term, okay? So the objective is to solve for the unknown variable, and our unknown variable is x. Okay, so we need to undo all of this math in order to get the x by itself. The toolbox is basically what the strategies are going to help me to solve this problem. We can use SADMATH to solve any kind of equation. We can use the inverse operations and undo our problem. And then, of course, we can always check it. If we have an answer and we solve for it, we plug it back in and see if our answer is correct, okay? So I'm going to model this example for you all. A lot of us are really strong in solving equations, and I just want to add a few tidbits on how to help you simplify your work so that you can submit your worksheet and exit ticket. So here we go. All right, so again, my goal is to solve for my unknown variable, 4x squared. So I go to my simple inverse operations. I like to draw my wall. I see SADMAP, so I'm going to write it out. Again, you don't have to use it. Do I see subtraction? The answer is yes. I see it here with minus 10, so the inverse is to add 10 to both sides. Okay? After I add 10 to both sides, these cancel. And I bring down this term, and this turns back into 4x squared equals 268. Okay, cool. Now I go back. Do I see addition? I don't see any of that happening. Do I see division? No. Multiplication? Yes. Okay, so what's happening between 4 and x squared is multiplication. So the inverse of that is to divide. So I'm going to use a different color. Divide by 4. Okay, divided by the coefficient in front of x squared. That then brings down x squared equals, and then we divide 268 and 4 in our calculators, and we should get 67. So now here is where our newish type of strategy comes in. We have x squared equals 67. Now, we technically do not have the x by itself just yet. So I'm actually going to rewrite this up here. Kind of smaller. The x is not by itself. So to undo squaring the x, we need to take the inverse. The inverse of squaring is to take the square root. So here I am at the exponent version. Now I do see an exponent. I need to do the inverse of it. So I'm going to take the square root. So we're going to use the radical symbol. And we're going to take the square root of x squared and the square root of 67. Okay, remember we still have that wall. So it's kind of like what happens on one side of the equal sign happens on the other. Okay. Now, again, I said in our vocabulary, squaring is the opposite of taking the square root. That means that they cancel each other out. Just the same as adding and subtracting cancel each other out. The same here. So this means that this square root symbol and that square, they cancel each other out. And so all I'm left with is that x. Okay? Think about x squared is x times x. So if I'm undoing a squared, I'm probably only going to be left with one value. Now, let's think about the square root of 67. So some of us are about to type that into our calculator, ting, 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 and we're going to get a long decimal number, right? Well, when we're talking about square roots and radicals and simplifying those expressions and those equations, we can use this radical symbol in order to write our final answer, okay? So there is no, So what I want to point out is if we were simplifying the square root of 67, we would first look for a perfect square. Well, there isn't a perfect square in 67, so I am not able to reduce this anymore. Okay, now, does that make my final answer only the square root of 67? Not quite. The square root of 67 is going to be positive and negative. Okay, and that is going to be my final answer. Now, you're asking, why is it going to be positive and negative, Ms. Meekins? Well, let's think about squaring, right? I'm saying it again. Squaring means multiplying a number by itself. Well, if I do 4 times 4, I get 4 squared, and that's 16. Well, if I did, let me get a color. If I did negative 4 times negative 4, I also get positive 16, right? So what that's telling us is that when we're squaring, we can have both a positive version and a negative version, because squaring it with that positive, with that even exponent makes our values positive. So when we take the square root of something, we're always going to end up with 2 values, the positive version and the negative version of that square root. Okay, so let's keep going. Now, before you move on to the slide, I definitely want you to go back into that example and pause it as many times as you can. Solve it again. Make sure you see why the steps were taken the way they were, and have any questions about that. Now, we're going to go into this second example, which looks a little bit advanced and tricky, but it's honestly not. And then I'm going to give you some pointers at the end, and we'll be done. All right, so now we have our second example, right? We have x minus 2 squared, so the entire function is squared, minus 25 equals 0. So what I do, draw my wall. Cool. All right, do I see subtraction? Yes, I do. I see subtraction twice, right? We see minus 25, then we also see x minus 2. Well, x minus 2 is in parentheses, so we're not going to get to parentheses just yet. So we're not going to address that subtraction. We're going to address the subtraction of the minus 25. So the inverse is to add 25. Cool. So then we bring down this entire parentheses. X minus 2 squared equals 25. Cool. All right, now we go back to our checklist. Do we see addition? Nope. Do I see division happening? Nope. Do I see multiplication happening? Nope. Do I see exponents? Yes. Do I also see parentheses? Yes. Okay. So what do I do with my exponents? Well, we have to eliminate our exponents in our final answer, because we only just want to know what the value of x equals. So the inverse of squaring is to take the square root. So we're going to take the square root of both sides. I'm going to take the square root of x minus 2 squared, and I'm going to take the square root of 25. Okay. Now, 25 happens to be a perfect square, which means there's one number, whole number, that multiplies by itself, and it gets us 25. And that answer is 5. But think about what I just mentioned in the previous video, or in the previous example. When we're taking the square root, we not only are going to have positive answers, but we're also going to have negative answers. So that's not a good color. I don't want to use that color either. Let's use green. So this is now going to be plus or minus 5. Okay? Because positive 5 times positive 5, 25. Negative 5 times negative 5, 25. Cool? Taking the square root, remember that square root and that squared cancel, and then we bring down our x minus 2. Now, you don't technically need those parentheses because there's nothing else, so you can take those off. Okay? From here, we now just solve for our value of x. And I really hope all the colors aren't confusing you. So I'm going to go back to a bold color. So now, again, I'm trying to get x by itself. So I see that subtraction again. It now shows up again, my parentheses. So I'm going to continue to solve. I'm going to add 2 to both sides. Now you're like, Ms. Meekins, how are you going to add 2 to plus or minus 5? That doesn't make sense. Well, you're now going to have 2 options. You're going to have 2 possible answers, just like we did in the previous. We had x equals the square root of 67 and x equals the negative version of square root of 67. And I'm going to go back and actually clear something up on that example. So here I have positive 5 plus 2. So I'm going to do positive 5 plus 2 equals 7. But then also, x equals that negative 5 plus 2. And that answer is sorry, y'all. That answer is negative 3. So our final answers in this problem is x equals 7 and x equals negative 3. And that is going to be my final answer. And remember, we can write our solutions as brackets as well. So again, look through this example, look over it, see what you understand, what you don't understand, what's confusing. Really want you all to reach out and ask for help. I really hope that this was helpful. We can keep our answers in that radical symbol, okay, which is right here. We can keep it in that symbol, and it might simplify into a perfect square. Or we will always have two possible answers, okay? Because we're taking that square root, we're going to have the positive version and the negative version of the square root. That doesn't mean that you're always going to have a positive and a negative. Let me see my pointer. That doesn't mean you're going to always have a positive and a negative here, but you will always have a positive and a negative here, okay? That. So plus or minus is the same as positive or negative, all right? This can get a little complicated in the problems that you all are doing for this lesson, and it will increase as the days go on. So I really do want to make sure that you are learning and perfecting your work. So reach out, okay, or join Zoom. And anytime I have those Zoom hours, come and get that help, y'all, okay? Love y'all. Talk to y'all later, and I'm out. Bye.